Okay, so we're in section 8 of the homework. I want to talk about one of the evils of giving students notes, and I really mean this for the more naive students. What they do is they look at the notes and say, and actually, I've actually seen students do it. They look at the notes and they point at them and say, boom, 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 boom. Gee, everything has been done. Thank God for that. I don't have to do anything. It's not me about, it's not about me doing the work. It's about you doing the work. All right. Now that's not a mystery to you, but if you don't do the work, if you keep pointing and say someone else has done the work for you, then you're missing the point of your education. Your education is you're supposed to do the work. Of course, why do we give you an answer key? So you can look at the answer key after doing the work. All right. So what I want to do is I'm going to go to the whiteboard. If I get stuck at any problems, I want to point out what I mean by if I were doing homework, I would sit in the classroom, I'd go back over the notes and look at them. Right? Like if I don't understand something, I'd go back over the notes and look at it. We spent a lot of time, going through methods and examples, and hopefully you paid attention during that time. Let me do another share with you though. And I got to do that, right? I got to share with you. Okay, we're on problem number 1. So what I'm going to do is just talk about problem number 1. Again, what I notice a lot of students will do, and I see them, certainly when I used to commute in the train, I would see a student take their lecture notes. And by the way, this is true all over the world. And what they do is they take their little fingers and they would do this. I see the problem. Oh, gee, look at this. Okay, great. Let me go to the next problem, do the same thing. They're really not even learning anything by doing that. You got to get your hands dirty here, so to speak. So what I want to do, I'm going to read it to you. It says, use the method of odd powers to evaluate the integral. Now, let's say you can't remember that. Go back over the notes and read that. All right. But let me see if I can remember. I always say I don't like to remember. I like to, maybe just have some kind of intuition about how to do the problem. And I'm thinking about it. Let me put this down for you. And I'm thinking this, I'll pull a 7 out. And then it says use, the odd powers. So I guess what I do, I guess I borrow one of the cosines, right? And then what I do, I guess thinking back over it, if I have any memory at all, I think what I would do is I'd rewrite the cosine squared using the Pythagorean identity. Now remember this, if this doesn't work, I'll just simply erase it and pretend I didn't do it. I'll do something else. All right, pretty easy to erase your work. What's cosine squared? It's 1 minus sine squared x. Right, I hope I didn't go too fast with that. Dx. Gee, it even got worse, didn't it? So I think what do I do? I can some kind of memory here. So what I'm going to do, I guess I use maybe a u substitution, right? So I'm going to say u equals sine x. If this doesn't work, I can always try again. What would du equal? That would be cosine x dx. Well, I'm seeing this, and I'm seeing that. All right, let's write this down now. Equals. I like to put the star there. I realize other instructors may not do that, but I do. And what's cosine x dx? It's du. And what's 1 minus sine squared? It would be 1 minus u squared. And again, I'm thankful we have an answer key to look at. We'll look at that too. What does this give me? 7 times u minus u cubed over 3, right? And then I'm going to do plus c over here. But remember, I don't want to, I want to put this back in the form I need it, right? I don't want u's. I want what's u? Well, you know what? I wrote it down. It's sine, right? So we get 7 sine u minus 7/3 sine. I'm sorry, I wrote u and I meant x. I got u's on my brain, right? Let me erase this off here. Sine cubed of x plus c. All right, let me look at my key and see. I want to see if I got that answer. And I'm looking at it. And I want to point I'm looking at. I hope you can see what I'm looking at. I'm seeing it, 7 sine x. and 7/3 sines cubed. Yeah, good job. All right, let's do number 2 now. All right. Wow, another tough problem here, huh? So again, you might say stuff, I'm really not familiar with this, but let's give it a try. I guess this second might be a little more difficult, but let's see, let's write this down. So method of odd powers. So I'm gonna write this down, sine x times, well, that would be sine squared, right? Maybe we should write that down for you. Times cosine. Wow, I don't know if I can do that. I'd say that's, I'm gonna be a facetious there. I want to point out, we don't write problems you can't do. Could you write problems that you couldn't do? Of course. There's an infinite number of problems we can't do. That wouldn't be fair to you. We want our problems you can do. What do I do now? Well, I guess I rewrite the sine. I'm sorry, sine squared in terms of cosines. So it'll be 1 minus cosine squared of x. And this is going to be cosine 14th x dx. How do I do now? I can remember now. Well, I guess I do this u thing, right? So I let u equal cosine of x. So du would equal minus sine x dx. Well, I'm kind of seeing it. And I'll put this over here now. I'm kind of seeing it. And what do we get over here? Let me underline something for you. I'm seeing sine x dx, right? And what's that equal? Minus du. All right. And then I'm seeing this 1 minus cosine squared. Well, that'll be 1 minus u squared, right? And then, cosine of x is just u. So this is u to the 14th. Well, I need to simplify that. And I'm going to do that. And what would I get? I would get, let's see, minus u to the 14th. And then I would get u16, right? Now, what's nice about having answer keys, I make mistakes. You make mistakes. If I have an answer key, it's not like I wanted to get the right answer. I have immediate chance for feedback, self-assessment, so to speak. Let's write this down. It's going to be u17 over 17 minus u15 over 15 plus c. And what was u? It was cosine, right? So what do you get over here? Cosine to the 17th power of x over 17 minus cosine to the 15th power of x over 17 plus c. Again, I'm kind of wondering, did I get the right answer? Did I misread it? Do I misunderstand? Did I make a mistake? I don't know. Let's look at the key. Box this thing over here, pull it to the side. I'm going to copy it. Back, whoops, sorry about that. I'm going to paste it over here. Blow it up a little bit. Get my red pen out. Did I get the right answer? Oops, I copied wrong. You notice that? Get my eraser out. That's an awful thing happened over here. See that? What's supposed to be? This thing. Glad I looked. I'm going to make a correction now. I'm good. Black ink. Sorry about that. My red ink out again, plus C. Good job. Next page. Right, made a mistake though. Caught it. Well, this one says evaluate the integral, right? You know what the first thing I want to do? I think odd power is going to work out pretty nicely, right? So let me do that. Because we just did 2 examples of odd powers. I might as well continue to do that. So let's write this down. And I'm gonna try to go as slow as I possibly can. Let's go back to black ink, right? I'm getting a little better though. So it's going to be cosine of 3x times cosine squared, which was 1 minus sine squared 3x dx. Then what would I do? I guess I do a u substitution, right? So u, and let the u be what? Sine, right? The du would be cosine 3x times 3 dx. Well, I notice what some students do now, they actually put the 3 here and 1/3 over here. All right, then they say, I see it now. All right, let's write this down now. 1/3. All right, I gotta be careful now. I know what I mean by that. This 0 here corresponds to an x, but I'm going to the land of u's. So what do I get? I get the sine of 0, because 3 times 0 is 0. What's the sine of 0? It's 0. All right. It's tough. I'm not saying it's going to be easy for you. So I guess I got to do this now, right? So what do you get? This corresponds to the limit on the x. I'm going to the land of u's, right? So sine of, that would be 3 pi over 2, right? 3 pi over 2. What's the sine of 3 pi over 2? It's -1. Now, someone says, do you ever make mistakes with arithmetic or simple algebra or trigonometry? Of course I do. The point is that I'll know I made a mistake just looking at my answer key later. I'm not going to look at it yet, though. So I'm going to put this 3 cosine x 3x down. And what's that going to be? That's going to be du. That's pretty simple. And then what do you get on the inside? Well, you get 1 minus u squared. It looks like a really simple problem, doesn't it? So what do you get over here? 1/3. The antiderivative, that's going to be u minus u cubed over 3, limits of integration 0 to -1. Whoops. I didn't mean to do that. I have I touched something I shouldn't have touched. Let me see if I can do that. So you get 1/3. I'm going to put -1 in this. It's -1 plus 1/3. And then you get -1/3. And what do you get there? You'd get 0, right? That's nice and simple. And what do you get there? 1/3 minus 2/3. Basic simple arithmetic, by the way. That's going to be -2/9. All right, let's take a look at our K. And again, there's work down there. Again, if you're really struggling, you might have to read through the work. But I feel pretty comfortable now. All right, I feel pretty comfortable. All right, let's go to the next page, number 4. And number 4, I'm looking at it, and I don't know. I love the fact that they give me hints, but hints only work if you understand what they're telling you to do. And what they're telling me to do is they're telling me to evaluate the integral using double angle formulas to reduce it. So you know what? I got to remind myself about the double angle formulas. I'm going to do that on the side for you. And I'm going to put down, cosine, because I see cosine in the problem, by the way, 2 theta. I'm just reminding what you did in math, 120. Yeah, 120. So that's going to be cosine squared theta minus sine squared theta. That's one identity. Another identity I could put down is 2 cosine squared theta minus 1. And then I can put down 1 minus 2 sine squared theta. All right. So I'm going to write down what I think I want to use, but I'm going to say if I think I want to use it, but I don't want to use it, I can always erase it and say I didn't really want to use that to begin with. But I think what I want to use is cosine of 2 theta is equal to 2 cosine squared theta minus 1. But I'm going to try to isolate the square now. So cosine of 2 theta plus 1 over 2 is equal to cosine squared theta. Let me see if I did that right, by the way. So I see the 2 cosine squared theta minus 1, add 1 to both sides, divide 2 by 2. I feel good about it. So I'm going to look back over the problem. I noticed I got 8 cosine 4. So I want cosine 4. So I'm going to put this down now. Right. So let me put this down. So cosine fourth power of theta. I'm going to go back to the y later. Don't worry about that. So I got to square that thing, right? So if you squared the bottom, what would you get? 4. I hope that's not going too fast with that. If you square the top, what do you get? Cosine squared 2 theta plus 2 cosine 2 theta plus 1. All right. Now, by the way, I'm still seeing the square. I don't want to square. I want to go to those linear terms because they're so much easier to integrate. So I'm gonna try to do that again. And I want to really, what I'm focusing in on, I'm focusing in on this business over here. And let me see if I can do it. So cosine fourth power of theta. There's a reason I'm using theta. We'll go to the y's later. This is 4. And what's cosine squared 2 theta? Well, I'm looking at that formula. It's going to be cosine 4 theta plus 1 over 2. Right. All I did was, 2 theta goes with, that's 2 times 2 to the 4 theta. It's not a big deal there, right? Plus 2 cosine 2 theta plus 1. I'm going to keep writing it down now. And I'm going to kind of split it. I got all kinds of linear terms now. So this first guy, we'll go slow because I realize, some people are faster than others, right? So this would be 8. What do you get over here? Cosine 2 theta. Well, 2 divided by 4 is 2 and then a quarter. I'm going to keep going. Yeah, it's work, isn't it? So you get cosine 4 theta over 8 plus 1/8 plus cosine 2 theta over 2 plus 1/4. That's not so bad, right? That's still the cosine 4 theta. Again, I want to go back to the problem, and they want to do 8 times that. So I'm going to put that down. 8 times this side, 8 times this side. And I get 8 cosine 4th power theta is cosine 4 theta plus 1 plus 4 cosine 2 theta plus, that would be 2, right? So 8 cosine 4th y, yeah, I'm going back to y now because it was y in the problem, would be, let's write this down. It's cosine 4 theta, not 4 theta, right? It's 4 y plus 4 cosine 2y plus 3. All right, so I'm going to write that integral down now. And what's the integral they want me to do? And I'll look at it again. Don't worry about that. 8 cosine 4th power of y dy is going to be cosine 4y plus 4 cosine 2y plus 3 dy. Now, I'm going to go back, see if there's any limits on that, and there's no limits on that. We'll look at the key later, by the way. Could I integrate that guy? Yeah, linear powers tend to be a lot easier to deal with than these 4th powers, so I think I can do it. And what do you get? What's the antiderivative? Well, let's see, sine, right? Over 4. We'll check it later. This is going to be 4 sine 2y over 2 plus 3y plus some constant of integration. Let me see if there's any simplifications I can do. Then we'll look at our answer key. And I'm hoping with all that work, I don't have to redo the problem. Or if I could see a small error and then correct it. And it happens sometimes too. I see a small error, like I did in the last problem, I copied wrong, right? Let's take a look at this. It's tough. All right, so did I get the first term, sine 4y over 4? Bingo, I got that. Feel good about that. Did I get the second term, which is 2 sine 2y? Gee, I got that. Did I get the third term, 3y? Gee, I got that. Did I get the constant? Yeah, I got that. Everything looks good. All right, let's look at this one over here. And depending on teacher you have, some teachers say, oh, you have to derive these reduction formulas. I'm going to say to myself is, I don't want to derive that reduction formula. You could, but I just want to see, can I apply it? So to do this, what I got to do is I really have to think about this. And I'm going to tell you what I'm thinking about. Looking at the problem, are they in the form I want, which is sine to an nth power? I'm seeing that, and cosine to the nth power. I'm seeing that. So let me write this down for you. And if I can understand, what's m? M is 3. And what's n? Oh, I don't have m down again. What's n? N's 2, right? Well, let me go over here and see if I can write that down. Well, the bottom's easy, right? What's that going to be? M plus n. 3 plus 2 is 5. What do you get on top? Sine m plus 1. Well, that's 4. We'll check the key later. Times the cosine of n minus 1. Well, that's going to go to the first power. Plus, boy, let's hope this gets easier, right? What's n minus 1? It's 1. What's m plus n? It's 5. Well, I'm not going to say it's going to get any easier, but I don't know. Maybe it will get easier. And what do you get over here? Sine to the m. That's sine cubed, right? Times cosine. 2 minus 2 is 0, right? It's a 0 power of the cosine. It would have to be 1. And then I get dx. All right, so I'm going to say, what do you do now? Well, what I want to point out is, and again, I really want to emphasize this over here. I want to point out, did things get easier? And they did get easier. For example, I'm looking at this. I have to integrate that, by the way. And I'm looking at this. And I hope you realize that life did get easier, but it's not over yet. Now, have I done something like this before? I have, and I want to continue doing it. All right, so I'm gonna say that I can take this. I'm sorry about that. I can take this and continue it. And I'll write this down for you. And what's going to be equal to? Well, let me put this up a little bit. Sine. We'll look at the key later, by the way. By the way, let me see if they ask me to do that. Yeah, use it to evaluate. I'm not done yet. Hopefully the answer will be on the next page, by the way, because the answer is not there. But at least I got part of the work there and can look at that for you if you like. Cosine x over 5 plus 1/5. And again, I'm hoping you can remember, right? I'm hoping that you can remember. Let me just, you know what? I'm going to start to erase some of the work from a prior problem because it's in my way. I don't need to see that anymore. I'm done with that. All right. All right. That's sine cubed, right? So I think I remember this, right? And what would you write down? Sine x times sine squared, which is 1 minus cosine squared. Now, I understand that some students say it's just too much to write down over and over and over again. But you got to learn to do that. You know, take notes, write things down. I need my star over here. And I'll write down what I want to write down. Maybe I should write down for you. So u is equal to cosine x. Du would be minus sine x dx. Well, you know, I got to revise my work now. Put the minus sign over here. And what would I get? I get on the inside, I get minus sine dx, which is du, right? And then we get 1 minus u squared. All right, let me keep going. This would be sine 4th power x cosine x over 5 minus 1/5. That would be u minus u cubed over 3 plus c. Remember, we have to put back in what u is, and u is cosine x. hopefully have some recollection. Again, I'm going to erase what's over here. It's annoying me. Push it up a little tiny bit. Get my eraser out again. We'll look at the answer key later, okay? So what do you get over here? Equals sine fourth power x cosine x over 5. Let's see, minus, that'd be a 5. What's u? It's cosine x. Plus, that would be a 15, right? And what goes on top? Cosine cubed x plus c. That's a 3. All right, I gotta go to the next page, grab the answer. Who knows, maybe I got it wrong. Box over here. And I want to see if I got the right answer. Oh, you know what? I don't think I copied it. That was a copy from the last one. And be honest with yourself. Did you get it? Sine fourth, cosine 5, good. Cosine cube over 15, good. Minus cosine x over 5, good. And plus c, everything's looking good. All right, nice to have an answer key. All right, let's go to the next page. And we're going to do number 6 now. And what's number 6? Evaluate the integral. Well, it looks kind of easy to do. Be honest with you. I think it is anyway, maybe not. I'm always deceived and think things are easy, but let me just take a look. I'm going to say u is equal to cosine of x. If this doesn't work, it's no real time loss, by the way, minus sine x dx. Well, yeah, I think it is easy. So minus, that would be u to the 6th du. And we'll check the answer key later. So it's going to be minus u, I put a star over here because I want to forget, u to the 7th over 7 plus c. And what's this going to be? It's going to be, let's see, minus cosine to the 7th x over 7 plus c. That was easy. That's a relief. When I say it's a relief, I don't know if it's right. Let's take a look. Looking at this, things are looking good. All right. So, this one over here, it'd be nice to get linear factors, right? Because those quadratic factors are really tough. And I think we did something before about those linear factors, right? So let's see if we can do it again. Repeat what we've done in the past. And let me write that down for you again, right? What we've done. And so can you remember what you've done? Sort of vaguely, right? So cosine of 2 theta. I think you remember doing this, right? I wrote down 3 different identities. This one I'm going to write down 1 minus 2 sine squared theta. And I'm going to try to solve that. That's 2 sine squared theta. I don't want to make any mistakes, right? So 1 minus cosine 2 theta. I think I did okay there. And then sine squared theta would be 1 minus cosine 2 theta over 2. All right. These are things that were covered in Math 120, by the way. All right, let's take a look at that and see if that applies. Yeah, I think it does. I can put this down now. So sine squared 2x would be the same thing as 1 minus cosine of 4x over 2. Now that's linear, by the way. It makes it easier for me to deal with the problem. So I'm going to write that down. So this is going to be 0 to pi over 2. And then I get, 1 minus cosine 4x over 2 dx. All right. So I'm looking at it. I definitely want to do it. And someone can say, I can do this really quickly. I have to repeat this over and over again. We're in no position to tell you to go slow, right? No position to tell you to go slow. We really want you to go faster. This is a very competitive world, and the faster you can do something, the better. However, going fast and getting it wrong is of no benefit to anyone. All right. So I'm gonna take my time with this, and I'm gonna say, I'm done with this part, by the way. I'm not gonna look at that again. If it's wrong, I'll come back and I'll have to correct it later. But I'm going to say u equals 4x, and du would equal 4 dx. All right. So why would you do that? I don't know. Maybe because I want to go slow. So I'm going to take this integral here, which is an x, and go to the land of u's. So if x is 0, u would be 0. Let's see. If x is pi over 2, what's 4 times pi over 2? 2 pi. And then what do you get? You get 1 minus cosine of u over 2. I'll put it into two different terms, okay? And then what's the dx equal to? It's actually du over 4. So I'll put the du, and I'll put a quarter over here. Again, I'm gonna keep doing it. Let's see if I can get it. I'm gonna factor the 2 out. I get 1/8, 0 to 2 pi. What do you get there? I guess you get, because I factor 2 out from the bottom, you get 1 minus cosine of u du. Let's keep going. All right, these are equal, by the way. It's 1/8. The answer of 1 is u minus, well, that would be sine of u, right? Integration 0 to 2 pi. I gotta do my arithmetic. You would get 2 pi. Sine of 2 pi is 0. That was nice. Minus 1/8, 0, and the sine of 0 is 0. It looks pretty easy. What do you get? You get pi over 4. Okay. I'm going to go to the next page, because I don't think the answer is on this page here, is it? Number 7. I hope to see pi over 4, right? Wow, that was easy. All right, let's do this one over here. And again, I'm not going to do a difficult problem sets. I realize some people say, oh, I'm getting tricked with these numbers. No, you're not getting tricked. We wouldn't trick you. Let's write this down. I'm getting a little better. Let's see. 0 pi over 2 cosine 9x. And they have cosine squared, which is 1 minus sine squared, right? Dx. I'm going to say u is equal to sine 9x, and du would be cosine 9x dx times 9. Let's see if we can do that. All right, so I'm going to land to use. We have a key to look at later. So let's see, sine of 0 is 0. Wow, 9 pi over 2. All right, so let me just go through the wheels on the bus, right? So you get, that would be 4, 9 pi over 2, 8 pi over 2, 9 pi over 2. So you coterminal at 90 degrees. So that's going to be 1. Right, I hope I didn't go too fast with that. But again, if you're looking at this and saying, well, I don't have the prerequisite skills, this is one of the big issues in life. You're moving forward, and it's unfortunate in school we actually move people forward that don't have the skills. Like if they're doing poorly in class, and then we say, okay, it's just enough to get out, then we give you to another thing. It's like building a house where the foundation is not, constructed, and you can't move forward. That's why you have to go back and shore up those deficiencies. You really have to, right? They're going to build up and your house is going to collapse in no time at all. But anyway, what do you get over here? I lost track of what I was going to say over here, but I would definitely get 1 minus u squared though. I know I see that. And then I'll underline for it. I'm looking at this guy over here. And what is that guy going to be? That's actually 1/9 of a du. I'll write that over here. Well, I got to be honest with you. I like the way these numbers are working out for me. This is going to be 1/9 u minus u cubed over 3, Lenz's integration 0 to 1. I did it again. I touched something I shouldn't have touched. And what do you get there? 1/9, 1 minus 1/3, minus 1/9 times 0. 1/9, 1 minus 1/3 is 2/3. And this is going to give you 2/27. Took it the key. If I make a mistake, I'll fess up to it and I'll do it over or look for my error. So we're doing okay. Yeah, a little boring over time. I really mean it. I'm looking at this and I don't know what to do, but I guess I'll try something, right? I always say, if I get something I can't do, I'm doing the wrong thing. I got to try again and again and again and again until I get it. Let's take a look at this. And the answer is not there. So I guess I got to struggle, right? Let's take a look. Equals 0 pi over 3. Let's see. I guess I could do this. Sine 6 power x times cosine of x times cosine squared, which will be 1 minus sine squared, right? And let me use my u, sine x. Remember, if it doesn't work, I can try again. Du cosine x dx. I'm seeing that. It's a miracle. By the way, it's not a miracle. We write problems that work beautifully. We really do. I can't say that enough times to you. All right, I'll put the equal sign down. Let's see, sine of 0, 0. And sine of pi over 3. Let me remind you, pi over 3. That's 180 degrees over pi. That's going to be 60 degrees. A 60-degree triangle looks like this over here. And what kind of ratios give you over there? Well, I hope you remember from your trig class. You're really almost like grade school triangles. And let me see, 3 plus 1. Yeah, it looks pretty good. So what's the sign of that? Well, that would be root 3 over 2, right? And don't worry, if you make a mistake, we have an answer key to look at. And what do you get over there? Well, that would be u to the 6th. And then you would get 1 minus u squared. And cosine x dx is just du. Let me keep moving forward. We have a key later. We'll look at that. I know I said a lot to you. We're trying to encourage you to do the same thing, by the way. And what do you get? u6 minus u8 du. Hopefully I didn't make any mistakes, or if I do make a mistake, I'm about to catch it. That's going to be u7 over 7 minus u9 over 9. Limits of integration, 0, root 3 over 2. I'm going to do something that some students find strange. I'm going to factor the problem. All right, I'm going to factor it. And I'm going to factor out 63 in the bottom. I know it sounds crazy, right? Maybe I should go through that with you. So if I did 63, what would you get? You would get 9u7 minus 7u9. I would factor out, and this is going to sound even more crazy to you. I'm going to factor out u to the 6th power over 63. And what do you get? 9u minus 7. That would be u cubed, right? So I'm going to say u squared. Someone says, why'd you do that? To make my arithmetic easy. All right, I'm going to see if I can do it. 1 over 63. Now, u to the 6 is going to be that number squared, which is going to be 3/4 to the third power. That's going to give you 27. Right? We'll do thing reductions later, right? And 4 cubed is 4 times 4 is 16, 64, right? 9 root 3 over 2 plus 7 root 3 over 2. And if I square root 3 over 2, what do you get? 3/4. The second term is going to be 0. All right. I'm going to keep going through it. I know someone says, do I need to do arithmetic? It would be nice if you could. All right. It'd be kind of embarrassing if you can't do arithmetic, especially when you get to a job and they give you an arithmetic test, you can't do it. But I'd see if I can do it. That's all I can say. I'm going to do by 9, right? So 9 goes into 27 3 times, right? And 9 goes into 63 7 times, right? And 3, well, 7 times 64, right? Let me write that on the side for you, 7 times 64. Well, 7 times 4 is 28, right? 7 times 6, well, 21, 42, 42, 44. And what do you get over here? Well, let's take a look. I see a root 3 coming out. And what are you left off with? Well, come down to 8, isn't it? And let's see what you get over there. 36 plus 7 times 3 is 21, right? And let's see what you get. 36 and 21 is 57. And 57 times 3. That's 150 and 21, 171. I got to check that again. 36 and 21 is 57. 3 times 57. 3 times 57, 150 and 21. 150 and 21 is 171. I think I did okay. What's 8 times 4, 48? 8 times 8 is 64. Let's see, 8 times 4 is 32, plus 6, 38. 8 times 4 is 32, and 3, 35. Make sure, 32, yeah, 35. I made a mistake, it's probably in the arithmetic. On the next page. I made a mistake in the arithmetic. I want to copy this though. Oh, by the way, I want to point out, okay, the arithmetic might be tough here, but you should nonetheless be able to do this without using a calculator. What I want to do is, we're at the last problem, right? So if you're exhausted, I understand that, but I want to see where I made that mistake. And you may know where I made the mistake, but I don't know where I made the mistake. I'm going to take my little thing here and paste it right over here. And this one thing I want to encourage you to do is, kind of look at what happened. Ask yourself what went wrong. And let's see if I got, if I'm getting what they say I should get. And I want to circle what I'm looking at. Did I get what they said I should get? U7 over 7 minus U9 over 9, root 3 over 2, 0. I got the right bottom. I'm getting the wrong top. I got to look at my work again. I hate to do it to you. I'm going to do it again. And what I'm going to do is I'm not going to do this. I'm going to do what's on top now. I'm going to do it again. It's going to be painful though. So I'm going to do this. I'm going to do U7 over 7 minus U9 over 9. And I'm going to simplify again. 7 times 10 is 63, right? So you get 9u7 minus 7u9. And then I'm going to factor out 63 on bottom. It's nasty. I'm sorry, 63. I said I put 64. I'm going to factor out u6. And what am I left off with? 9u minus 7u cubed. And I'm going to plug in root 3 over 2 now. And I'm curious if I made a mistake. So I want to do it to the 6th power, right? So if I square that number, what would I get? I'd get 3/4. And I need to cube it now. And that would give me 27, right? And 4 cubed would be 64, right? I'll write that down now. Make sure I did that right. u6. If I square it, it would be 3/4. If I cube that, 27/64. 9 root 3 over 2 minus 7 root 3 over 2, and then square it would be 3/4. Oh boy, a lot of work here, right? I guess I'm going to reduce by 9. That would be 3. And 9 goes into 63 7 times. I'm going to write that down for you. And common denominator of 8. 36 root 3 minus 21 root 3. I think I know where I made the error before. I think I added those two numbers before. Remember that? I'm kind of remembering that now. Now, so why do you keep going over that if you know you made an error? I don't like making errors, and you shouldn't either. You really shouldn't like making errors. But anyway, let me keep going through it. And I get 3. 7 times 64. You get 8. What do you get on top? 36 minus 21, which is going to be 15 root 3. And then I get 45 root 3. Let me check out the bottom. 8 times 7 is 56 times 64. 6 times 4 is 24. 36, 38, 20, 32. Yeah, we got it. So a mistake was made. And again, I think the mistake, when I wrote down the other problem, I wrote down plus between them, and it happens. Sometimes you get tired, you write the wrong things down. Let me just point out that you're going to be faced with exams. I'm not going to say necessarily at Essex, but at other schools where finishing a problem may be too tedious for you. So what you have to start to realize is that you want to start to do a problem and get the initial steps correct, and then simply stop the problem because it's taking you too long with the arithmetic or you're making too many mistakes, and go to the next problem. Try to cut your losses though. The arithmetic at this level of the game is much less important than the actual integration. So again, what I mean by that, in the problem, I would certainly be looking, again, I can't emphasize enough. Like if you got to this stage over here, I'd be really happy. Now to go from this step over here, this took me the most amount of time. It took me a lot of time to do arithmetic. Was it worth it? Well, yeah, because I don't want to get the wrong answer. But you may say to yourself, I've done a lot of work. I should get credit for that. And you should get credit for that. If you make a mistake in arithmetic, I'd probably just blow it off. I was grading a student's exam, but other teachers don't. They want to see the arithmetic done correctly. All right. Thank you for paying attention. And I'll see you next time, hopefully.